Geometry, section 11.2, surface area of prisms and cylinders. Here I am at my website, and if you scroll down on my website, I want to show you a few things. Number one, I did add all of the chapter 11 answer documents right here, so please feel free to access those when the time is right, and you should be doing all the homework from the textbook and then checking those answers before you do the Socrative assessments. Also note that there is no 11.1. We've just decided to skip that for time's sake and for just getting the essentials across. 11.1 wasn't important. And also above that, you have something called 11.2 notes. That is a document that I would definitely have handed you had you been here, and we would have filled this out in class, taken about 10 or 15 minutes and used the book. Just above that on the website is the key, and I'm going to focus on some key items here on the key for section 11.2. Okay, and let me start by saying I'm going to reference these two figures. If you can see where I'm pointing, this cylinder here and this pentagonal prism here when I talk about things. The first thing I need to tell you is that we do not consider these to be independent things. Okay, it's not that a cylinder is something different from a pentagonal prism, or even that a pentagonal prism is something different than a triangular prism or an octagonal prism or whatever. Okay, they all go into the same category, and we can use basically the same formula for calculating the lateral area of all of them. Okay, now here's why I say that. You see this diagram right here, that figure that's at the top, that's known as a base, that's a pentagon. 5 sides, of course. Okay, so that is then a pentagonal prism. The three-dimensional figure that has a base that's a pentagon would be known as a pentagonal prism. Now, again, it doesn't matter if I make it a triangular prism where the base is a triangle. I should say bases plural because there are two. They're the parallel faces that are pentagons here. But if they're triangles or they're squares or rectangles or some other kind of quadrilateral or pentagon or hexagon or octagon or 20gon, they all fit into the same category as far as prism. And then if you change all those polygons that I just mentioned to circular, a circle base, a base that is a circle, that's a cylinder. Okay, so a cylinder really gets fitted into the same category as a prism. It's just a round prism, a circular prism, if you will. Okay, so as you look at this, as this notes, I think it's a little bit less than perfect because they are going to kind of distinguish out and say, okay, here's the lateral area of a cylinder, and it can be simplified to this rather than just using one for all. I'm going to use one for all. I believe you should use one for all. I think that's actually simpler. The second thing I would note, and again, I'm just referring to these two diagrams. By the way, I mentioned a triangular prism. Here's a triangular prism right here, right? That's what's filled in the blank there. Is think about this in terms of, if this were just like a cardboard thing, maybe it's a Pringles can, right? You could probably manipulate that. What if I just cut it open? What if I could just cut right here and flatten it out? That's what they're trying to show in this diagram right here. That rectangle, right? Again, if you just cut right down the vertical side of the shaft of a Pringles can, you could flatten it out and it would be a rectangle. Well, that's what they're trying to show here. Here's the rectangle. And that's a rectangle, of course, that we can find the area of. And that would be the lateral area. And then if you include the two bases, that would be the two circles on this prism. Well, that's then a surface area. Two important words to know. Lateral area doesn't include the bases. Surface area does. Same thing with the pentagonal prism here. If I could just maybe cut right down, like imagine this is something that's paper or cardboard, and I could cut right down this edge and flatten it out, you'd have a rectangle. Okay, now the rectangle would be the length that is the perimeter of this hexagon, or in the case of the circular one, it would be the length that is the circumference of the circle times the height, this height, or in this case, this height. And that's why our formula is going to be so simple. Okay, now you can read through the rest of this, find out what the circumference of the base is if you don't think you already know what the height of the cylinder is going to be. Quick note about that, the height of the cylinder is always perpendicular to the base. Don't think of it as being up and down, right? You are the height that you are based on whether you are standing up or lying down, okay? That's the same idea here. Your height, if you're only 8 inches thick, when you lay down, that doesn't make your height 8 inches, okay? When you lay down on the floor. Your height is your height. And that's the same thing with prisms. So the height is perpendicular to the bases, and the bases, and again, just kind of for context, the base doesn't necessarily mean bottom. The base, if I took this pentagon and I laid it down so that this was the bottom, the bases are still the two parallel pentagons. In this triangular one, the triangle here and the triangle here are the bases. Okay, I think that's enough from these notes. I do think you should read through the rest of that and make sure you understand what I wrote in there. You could print it if you want to. All right, so I spoke of a couple of formulas, and here they are right here. The lateral area is equal to PH, where P is the perimeter and H is height. Okay, P is the perimeter where H is height. Now, the way this works for something that's a triangle, rectangle, pentagon, like we've already seen, would be you should be able to add up the sides to find the perimeter of the base. That would be your P, the P that goes into this formula. The height, H, is perpendicular to those bases, okay? And same thing now, but if you think of it in terms of a circular prism, that's what we call a cylinder. If it's a cylinder, then the perimeter of a circle is 2 pi r. This is why we covered that in chapter 10 before we cover this lesson now. So that's why you might have seen on that worksheet that I just had up is the lateral area of a cylinder is 2 pi r h, because we would substitute 2 pi r in for h, and it would be 2 pi r h. I'm not going to give you a separate formula. To me, it's just the simple formula pH, and you are to know that the circumference of a circle is 2 pi r. That's the lateral area. The surface area then includes the bases, so it's the lateral area plus 2 bases. Now you might wonder, why is it 2b? Capital B means the area of a base. Two bases, 2b, because it's 2 bases. There are 2 bases. Okay. Now to illustrate this, I've got this rectangular prism drawn, and it's kind of the exception. The rectangular prism is kind of the exception, because to identify the bases is a little bit ambiguous. Okay. And what I mean again is, go back to the worksheet. There's no confusion here. The pentagons are the bases. There's no confusion here. The circles are the bases. There's no confusion on the triangular one. The 3 rectangles are lateral faces. It's the triangles that are the bases. But when I look at a rectangular prism like this, which 2 are the bases? You could argue really any 3 pairs. You could argue the green ones, you could argue the purple ones, or you could argue what I'm going to call the clear ones. I tried to add a 3rd color to this, and it just messed the whole thing up. So the bottom and the top, I'm just going to call those clear. I hope that makes sense. Okay. Now look, if I were to ask for the lateral area of this figure, and I was thinking of the 2 clear ones as the bases, you could calculate the lateral area, and it would be like this. Perimeter. Okay, now remember the clear ones, so the top and the bottom are the bases. So the perimeter would be like saying 16, 11, 16, and 11. No doubt if this is 11, then this is 11. If this is 16, then this is 16. If this is 5, then all these other verticals are 5. So I could go 16 plus 11 plus 16 plus 11, which would be 54. Times the height, which is 5. Okay, now that's the lateral area. If I were to ask for the surface area of the same figure, it would be 54 times 5 plus the area of 2 of the bases, which are 16 by 11. 2 times 16 times 11. 16 times 11 is 176, just to keep that a little bit simpler. And I'll just go ahead and do that math real quick on my calculator, just to see what the lateral area is. That comes out to 622. Okay, now what else could we do? Well, maybe you think the purple ones are the bases. You wouldn't be wrong to think that. We'd have to be clear. On a rectangular prism, we'd have to be clear. By the way, this isn't just a specific example for one, minuscule type. If you understand this, you understand the concept of the bases. If the purple ones are the bases, well, then the perimeter of a base would be 16 plus 5 plus 16 plus 5. That'd be 42. And the height would be 11. And if I were to then ask for the surface area, it'd be 42 times 11. Sometimes they ask for the surface area. Sometimes they ask for just the lateral area. The area of the 2 purple ones are 5 by 16. That would be 80. And let me just double check the math on that real quick. 42 times 11 plus 2 times 80 is 622. Not a shocker, right? And just to be fully complete, what if I thought the green ones were the bases? You're not wrong to think that. The green ones are the bases, then you're going to have 5 plus 11 plus 5 plus 11, which would be 32 times 16, which means the surface area would be the lateral area, 32 times 16, plus 2 bases, which would be 55. And just to be sure, I'm going to do that math on my calculator as well. And it comes out to 622, of course. And that's inches squared. So no matter how I calculated it, of course, it should be the same because that is going to be constant. It's 622 inches squared. You might think, hey, it's a three-dimensional figure. Why isn't it inches cubed? Inches cubed is for volume. We'll deal with that a little bit later in the chapter. This is still a surface area. This is still, if you think about it like a box that you might purchase food in or something, we're talking about the area of the cardboard or whatever the material is that is two-dimensional. Still a two-dimensional figure. All right. Try to be quick with these examples. Here's one that says use a net to find the surface area. I'm not crazy about the net problem, but very similar to the last problem, you could find the perimeter, which would be 44. No matter what you do, no matter which two you choose for a base, the perimeter would be 44. Multiply that by 11, that would be the lateral area, and then add it to 2 bases. Probably easier to just here to find the area of each one individually. 11 times 11 is 121. 6 times 121 would be that surface area. Okay, next one says find the surface area of a 10 centimeter high right prism with a triangular base having 18 centimeter edges. Quick note on a right prism, that just means that the edges, I should say the lateral edges are perpendicular with the bases. If it's not right, it might look something like this, where these, I didn't draw that very well, but where it's kind of tilted, if you will. Okay, not like that. We're not talking about that. And even if we were, the formula ends up being the same thing. No, but this is a right prism that has triangular bases with 18 centimeter edges. I will draw a quick picture of that. And just to give you an alternate perspective of the idea of bases being bottom and top, because I don't want you to think of it that way, please understand, and this is a huge point to make. I see students confuse this every year. The triangles are the bases. They don't have to be top and bottom. This triangle is a base. This triangle is a base. Anyway, it says it's 10 centimeters high, so that's this, perpendicular with the bases, and the edges are all 18. Now, the drawing's not quite to scale, but it should be good enough for what we need to do. Anyway, when you calculate a surface area, I think you should do it all in one line rather than, calculate the lateral area over one area and calculate the areas of the bases somewhere else and try to bring them together. Just start with this formula right here because they said surface area. The lateral area is the perimeter times the height. The 2 bases are 2 triangles, and you could do this one of 2 ways. I think that I will stick with 1/2 apothem times perimeter to not be too confusing there. Note the 2 P's here are the same thing. That's not always the case in this chapter, but for right now, perimeter means the perimeter of the base, and this P here is the perimeter of the triangle, which happens to be the base. Now, let me redraw that triangle. This should be the only long example of the lesson. I think I'm pretty close to being done, actually. This would be the apothem. If each of the sides is 18, that means that this is 9. And because this is an equilateral triangle, this angle here would be 30 degrees. This angle here would be 60 degrees. And we could use special right triangles to find out what A is. All right. And that A value is going to be 9 divided by the square root of 3. I'll let you process that for a second. Long leg divided by root 3 gives you short leg. 9 divided by the square root of 3. Now, if they had asked for it in simplest radical form, what we should do is multiply by root 3 over root 3, which would be 9 root 3 over 3, which would be 3 root 3. And you certainly can use 3 root 3, which I think I will do since I went through the motions of getting it done. However, it did say to the nearest whole number. So in that case, if you use 9 over square root of 3, you're going to get the same answer. Okay. But again, I did take the time to use 3 root 3 to get the apothem as being a simplified radical form, so I'll use it. Anyway, let's finish this up now. The perimeter would be 18, 18, and 18. That's 54. The height is 10 plus 2 times a half. If you wanted to simplify that to nothing, to 1 really, you could. The apothem is 3 root 3. And the perimeter, once again, being the perimeter of this triangle, which is the perimeter of the base, is the 54. And I do need to use my calculator here. So the lateral area would be 540. And then I'm adding that to 2 times 1/2 times 3 root 3 times 54. And I get 821 to the nearest whole number. Centimeters squared. That is exactly the number I got on my calculator, round to the nearest whole number. All right, so then let's apply that to cylinders. The radius of the base of a cylinder is 6 feet and its height is 9 feet. Find the surface area in terms of pi. There's that concept again that we talked about in chapter 8. Here's a cylinder, pretty rough drawing, but you get the idea. And its height is 9. The radius of the base is 6. So that's like this. And they want to find the surface area. Okay, so look, the surface area is equal to lateral area plus 2 bases. The lateral area is perimeter times height plus 2 bases. And the perimeter of a circle is 2 pi r. All right, so P becomes 2 pi r, H is still H, plus 2 times the circle formula, pi r squared. Okay, now a couple things. The r in both of those is the same thing. It's the radius of the circles. Secondly, don't be confused by 2 pi r squared. Every year I'll have somebody come to me and is confusing the circumference formula with the area formula. This is not the circumference formula. This is just 2 circle areas, twice pi r squared. Okay, don't confuse the two. We're not doing circumference here. In this portion of it, that's just 2 because there was a 2 here because there's 2 bases, and the area of a circle is pi r squared. All right, now everything that I just wrote here, I don't necessarily expect students to do that, but I just want to show you where the setup is coming from. The critical line of work would be right here. 6 in for the radius, 9 in for the height, 2 pi, and again 6 in for the radius, and it's squared. All right, now 6 times 9 is 54. Times 2 would be 108. That does mean that the lateral area is 108 pi, and I'm going to leave it in terms of pi because they told me to, plus 6 squared is 36 times 2 would be 72 pi, and treat those like objects, like terms. 108 pi plus 72 pi would be 180 pi, and that is in feet squared. 180 feet squared. Okay, we won't do the last example. All it is really is very similar to the problem we just did, except you are comparing the two. So they give you 2 different ones. You do 2 different calculations for 2 different cylinders and decide which one has the greater surface area. So you want to practice that one on your own, you can. This really should suffice. All right, I know that was a little bit of a long video. I thank you for staying tuned in till the end. Good luck on your homework.